Okay, let's continue with strings. But before doing that, let's look at this comment. So a line which starts with hash is a one-line comment, and the interpreter will ignore it, whatever we write. This is for our purposes to explain the code, to explain the pseudocode, what the function is doing, and so on, right? So whatever we write after this, it will be ignored by the interpreter. This is another, and what about multi-line comment, right? So we can just continue line 2, line 3, and so on, right? So this is one way to do it. There is another way to have multi-line comment is 3 double quotes. So anything between this will be a multi-line comment. Right? So Python will ignore all of these because it's a comment. It's for our purposes to understand code in future or what a function is supposed to do if someone else is modifying the code or reading the code or someone else is maintaining the code. So we should use comments in the functions or whatever code we write to explain what the function or the code is trying to do, so that in the future, some other maintainer, some other developer, or even you, when you look at the code after a long time, will be able to recognize what the function is trying to do. So this is all about comments. Okay, let's continue with strings, right? So we have seen this, right? We have seen this. So this is the print statement, but we also want to focus on modifying the string, because earlier we were looking at something like this, right? It says name and it was an F string, and name could be, let's say my name is Dave, right? And this worked. So this is one way of formatting it, and there are many ways to do it. So let's spend time looking at strings, string formatting, and some string operations which are very popularly used. So this is simple, but let's run it, right? So screen is already cleared. We run Python program.py, and we can see it works. Country is equals to I live in India. Now let's do string formatting in different ways. So earlier we were using F strings, but there's also, we can also do the same thing with traditional strings. Let's say I write my name is something, which should be inputted later. I live in somewhere, right? Now, basically, these curly braces are special even in traditional strings in Python. And how do we use it? We just write a dot format, and then whatever the value of first curly braces, and then the value of second curly braces. Let's see, right? What happens. So you can see that, right? My name is something which is name, a positional argument, and I live in this curly braces, which is country, right? Let's see if it works. I'll clear the screen, run it again, and see it works. So there's also another way so that we can use the positional arguments. This is position 0, this is position 1. So we want here the position 0 argument and position 1 argument, because we don't always want the same ordering, right? We might do it the other way. So this should also work, and it works the same way. Just to emphasize this 0, 1 thing, we can actually have the ordering the other way. Okay. Right. Now the first position should be here and the 0th position should be here, and it should show the same results, and it works, right? So you understood how this dot format style of formatting works. There's one more way, which is named arguments. Let's see. So what we can do is, similar to string, we can write name here. We can write country here. And this name and this country is special in this string because it is between these curly braces. But how will Python identify these is by keyword. So we can have name is equals to Dev, country is equals to India. So you can see, right, what is happening. My name is the variable name. I live in variable country, and formatting identifies them by the same keywords. Name equal to Dev, country equal to India, and it should work. Let's see, clear the screen, run it again, and it works, right? So this is, I prefer this way, but all of them are good. Okay, now we can also write name equals to name, country equals country, and same answer, right? Clear the screen, run it again. So this is about string formatting. We have already seen f strings, and also why f strings are better, because we don't have to write this format part, right? Which could be tedious. We can just add an f here and it identifies. So this is the f string style of formatting. And we can see that as soon as we added this f, the codeator is able to identify that this is a variable. This is also a variable and it should work. Let's clear the screen, run it again, and it works, right? So while we are formatting, can also have some number, right? Let's say cost is equals to 100,000. I can add my living expenses are cost, right? Let's see what we get. Clear the screen, run it again. So now if the variable is a number, there are various modifiers. We can write a colon and then add a comma. What will this do is it will format the number. We will see again. Now what you can see is that after 3 zeros there's a comma, right? This is a standard formatting in computers, right? After 3 0. So if we add one more zero, 6 zeros will be a million, and it will be easily visible in the results. So let's see what happens, right? So this is 1 million. Again, let's say if my cost was a fraction and I want to just display 2 decimal places, we can do a point to f, and let's see, here the screen, run it again, and we can see that the number also has its comma separations, and it has given you the closest 2 decimal places approximation, right? This is about formatting the numbers. Okay, let's do some text operations. So let's say I have a text, right? So let's say this is the text. I'm Devendra, I live in India. So let's look at indexing in various forms. So first one would be, I want to see if India word is in this string, right? So India in text is something which will tell you a true or a false. So because India is in the text, it will give me a true, right? We can also do not in text. India not in text. So this will be true only when India is not in text. So because it is there, it will be false. It's false, right? Similarly, you can also do indexing. So basically, this is a string, and the first alphabet is 0 indexed, then it is 1 indexed, 2 indexed, 3, 4, and so on, right? So this is the indexing. So if I wanted to take a subset, so this square brackets is how I can index a string. And let's say I want to start from position 2 and I want to finish at position 14. Let's see what I get. Clear the screen, run it again. And you can see it starts from position 2, 0, 1 is skipped, and position 14 is excluded, right? Which is this space is position 14. So this is how you index it. There's another way to index. If you wanted to start from somewhere till the end, if you just write 2 colon, it starts with A and it goes up to the end of the string. Let's see, you clear the screen, run it again, and you can see, right? It starts with A and till the end it goes. Similarly, if you want to start at I, you can run it again, right? So if I start from position 15, previously I told you this is position 14, right? So if I start from position 15 and then don't put anything after the colon, it will go till the end, and hence it is printing till the end. I live in India, right? There's one more way. How you can do it is like we start at the beginning and stop somewhere, right? So if I start at 14, stop at 14. So 14 is not inclusive. The ending part is not inclusive. So 14 is the space which will not be included, and it will start from the beginning till 13th alphabet. Let's see how it looks. Clear the screen, run it again, and there. So there's also negative indexing. For example, -1 is the last alphabet. Let's see. The last alphabet is this. So we can go like few alphabets back. Let's say -5 to -1. Clear the screen, run it again. Okay. So I is -6. Screen, run it again. Right. So this is -1, -2, -3, -4, -5, -6. So we start from -6 and we go till -1. Right? But -1 is not included. So this is the negative indexing in Python. Similarly, if you want to find something in the string, right? There's a function called find, and you can search for it. Let's say I want to find Dev. So text.find Dev. So this will return the index where we find Dev and where it starts. So it will return the index of this capital D here. Let's run it and see. Right, the index is 5. 0, 1, 2, 3, 4, 5, right? So this is find. Similarly, if I have something which is not there, it will return a -1 because it was not there. Okay, there are other functions which are used very commonly. There's one called lower. So what happens is it will convert the whole string to lowercase. Similarly, there is a function called upper. So it will convert the whole string to uppercase. And see, everything is uppercase. So there's also something called split. So what will happen is it will split the string wherever the space occurs. But before that, we have to cover lists. So let's keep it for now. Later on, we will see lists and then maybe come back here. There's a function called replace. Replace. And we want to replace, let's say, Devendra with another name. Let's say So what txt.replace is doing, it will find Devendra and it will replace with Ram. Let's see if it works. Clear, run it again. See, I am Ram, I live in India. So this replace function replaces something with something else. So there's a function called strip. So what happens is sometimes when we are feeding in the input, right? Sometimes by mistake we pressed in a lot of spaces at the beginning and whatever. So we can see that there's a lot of useless space in the beginning and in the end for whatever reason, right? It could be because the input was communicated, and while the communication happened, something got appended at the beginning or the end because of some logical error in someone else's code, whatever be the reason, right? So there's a function called strip, and by default, it strips all the spaces in the beginning and end. We should also print it without strip. Let's run it. See, the actual text is this, but after strip, we get what we had earlier, right? So there's one more thing about strip. You can give it a list of characters which it will strip. For example, we also want to strip, let's say, full stop at the end after India, right? And we also want to strip spaces. So let's see what happens. Clear the screen, run it again. And what we can see here is that this full stop is also removed because we had it full stop in the list. So this is strip. But yeah, I mean, if you don't provide any input, a default value is a single white space, which is this. This is the default. Even if you don't provide that, it will assume this is the default. Let's see, and it works, right? One more thing, string concatenation, right? Let's have txt2, which is I am is 34. So let's say if I wanted to concatenate these, right? So I can do a plus. So what I can do is text2 is equal to text plus this. And you can print text2. So what we have done here is text is this, and text2 is text plus another string. And concatenation will just create a new string which is this, and after this will be there. So let's see what happens, and you can see image 34 is appended after whatever there was there in txt. So this is the plus sign. There's also, I mean, we can be creative, and we know that something into 2 will be the same thing added twice, right? If I do txt into 2, it will be txt plus txt, right? Let's see what happens. Clear the screen, run it again. So what we can see is I am Devendra, I live in India. I am Devendra, I live in India. Because I did into 2, which is txt plus txt. If I do it into 3, it will be txt plus txt plus txt. So it will print the same thing thrice. Let's see. Okay. There's one more string operations which is very common, join keyword. So basically this is something called list. Let's say L is equals to this. So basically list is just a list of items. It could be anything. In this case, it's a list of 2 strings, hello, world. And the list could be any length, but in this example, we have a length 2 items, both are strings. It could be mixed also, but just to show the function join, we are showing this example. So what will happen with this is basically it will join all the strings in the list separated by this. Let's see, right? We had hello without spaces anywhere. We had world without spaces anywhere. And when I join all the items in the list with a space, we can see it prints hello world. And this is also very frequently used if people want to use it. So this is where I think we have seen enough of strings. Let's start with a new data structure called list. So list is just a list of items. In this example, it's a list of numbers. And obviously we can print the list, which we will do. Clear the screen, run it again, and we can print the list. We can also add items to the list. L dot append. Let's say I want to add 12. So in this list, append will add an item at the end. So let's see if we have added Clear the screen, run it again, and we can see that 12 is added at the end. So there's also a command called extend, which can add multiple items at the end. Let's see it in action. L.extend, and we can provide many items in the list. Let's say 20, 22, 24. So it adds 3 items at the end of the list. It adds 1 item. So what will happen is it will first add 12, and then it will add all these 3 items at the end. And let's see it in action. Clear the screen, run it again, and we can see, right, 12 has been added, and then all the 3 items has been added. So this is how extend works. Okay, now one more thing is list is something which is by reference, which means that its address is preserved and we can actually pass the address to a function. Okay, let's discuss that later. Let's continue. So we have seen append, we have seen extend. There's also a plus operator. Let's see that. So what happens is the two list, let's say the second list is 12, 14, 16, right? So what is happening is this plus operator concatenates the two lists. Let's see that in action. Clear. We see the plus operator concatenates the two lists. We can also see the length of list. So there's a function called length of L, and we can see 3, 4, 5, 6, 7, 8. The length is 8. Let's see that in action. And the length is 8. Right? We can also run some of the functions in Python on a list. For example, if I wanted sum, which is the sum of all the items in the list, 72 is the sum of all these numbers. Right? Similarly, there's a min which gives you the minimum in the list. There's a function which gives you maximum in the list. See, 2 is the lowest and 16 is the highest number in the list, which is obviously correct. There's a function called reverse, which will reverse the list. So let's say I want to reverse. We do a L dot reverse, print L. So we will see it in reverse. See? So now the list has been reversed. So L dot reverse reverses the list in place. It doesn't make a copy. So indexing, it is very similar to strings. Let's remove this. So L of 0 is 2, L of 1 is 4. So this index should give me 4. Again, -1 gives you the last item in the list, which is 16. We can also have a range similar to what we did in strings. So 2 to 4. So it will have item number 2 and item number 3. 0, 1, 2, and 3. So 6 and 8 will be the result of this. Similar to strings, it starts from beginning and ends at 4, not inclusive. So 0 to 3. It will print all these. Similarly, if we have starting at 2, ending till the end of the list, this is how we do it. It's very similar to strings. The negative indexing works in a similar way. Let's run this first. See, so from the beginning of the list up to the third item, 0, 1, 2, 3. Similarly, we start at the second item and we go till the end. So these two, this is how it works. There's also a way in indexing to skip items. So what happens is, basically what we're doing is from start to end, colon step size. This is the full syntax. So let's say I want to start from the beginning till the end, so we don't write anything, with a step size of 2. So we'll see that it skips one item. Every 2 items, it takes the first one. So we'll clear the screen, run it again, and what we can see is it prints 2, skips 4, prints 6, skips 8, prints 10, skips 12, prints 14, skips 16. So every alternate one it takes, which is the step, right? Now there's a function called ID, which gives you the address of the list. So ID, so what ID does is it will print the ID address, physical address of the list, right? So let's see that. See, so this is the address of the list. And what happens is basically when you do, let's say M is equals to L, and then we will print address of both, ID of M as well. So it seems like we are assigning L to M. But what is really happening is we are assigning the address of L to address of M. So in a way, if we modify L, M is automatically modified. So first, let's see the address. Leave the screen, run it again, and we can see that both addresses are exactly the same. And because of that, if I do an L dot append and print M, L dot append, let's say we add a string to the list. Now, obviously, L has hello at the end now, but we'll print M. And we will see that because the addresses are the same, hello is appended to L as well as M. Let's clear the screen, run it again. And see, I printed M, which has hello, but I added hello in L, right? So this is special about list, and this can be actually used to pass values by address. Okay, we can discuss this again, but yeah, I mean, you get it, right? So this equal signs doesn't really copy the values to M. So M and L are not independent. So if you want to really make a copy of it, you have to do this. And now it will make a copy. And if we look at the IDs, it will be different. Let's look at it in action, see it in action. So now if you look at it, see the last 3 digits, right? It has made a copy to a new address. And because we appended hello in L, M is unmodified, and you can see M doesn't have hello. Earlier it was having hello, right? Okay, now what else we can do? We can also do a pop. Pop is a command. So let's see where our sorted list. So pop actually removes the last item from the list and it stores it or returns it. So item is equals to L dot pop print item comma L. So let's see that in action. So what happens here is what pop does is it removes the item from the end of the list and returns that item which we are assigning to the variable item. So item should be 10 because that's at the end of the list. And after popping it, that item is removed. So we can see that this item 10 is assigned to the variable item. And this list doesn't have 10 anymore, which was at the end, right? Similarly, there's a delete operation. We can delete at any position. Let's say I do a delete of L at position 2. So what is position 2? Position 2 is value 6, 0, 1, 2. It will delete 6 and let's see if it deletes 6. Clear, run it again and we can see that it has deleted the item at position 2 because it's 0 index, 0, 1, 2. Okay, so let's say there's a random value like 3, 1, 5, 7, 2, right? So the ordering of items in this list is random, right? There's no increasing or decreasing order. So there's a function called sort in list. So we can do L dot sort, and after this it will do it in place and modify the list in such a way that it is in increasing order. So let's clear the screen, run it again. And what we can see is that earlier the ordering was not increasing, but after running this function sort on list L, it is increasing order. Similarly, sorting has a special key where we can also do a decreasing order of sorting. How we do it? We do reverse equals true, and the default value is obviously false. That's why it sorted in increasing order. So once I do this in reverse equals true, it will now be decreasing order. See, it is now decreasing. So this is sorting. Okay, if you look at this comment, right? List is called a mutable ordered sequence. So obviously we can see that it's an ordered sequence. It has an index. It's a sequence. It's ordered. It's mutable. Why mutable? Because we can append to it, we can extend it, we can add items, we can delete items, and so on, right? So that's why list is called mutable ordered sequence. But there's something called a tuple. Tuple, and how it is different is, but if you look closely, look at the brackets. So the variable t is a tuple, the variable L is the list. And in terms of creating it, this is how we do it. The difference between list and tuple is that tuple is immutable. There's no append operation. We cannot add items. We cannot remove items, right? So that's the difference. For example, if I do a t dot append, it will give me an error. Let's say I want to add 12 to t, and we print t. Let's see what happens. We'll run it, get the screen, run it, and see, we get an error, right? Attribute error, tuple object has no attribute append. So it has no functionality of appending. So that's why it's called immutable, which cannot be changed. So that's all about list. Before we move forward, I wanted to cover two things. First is on strings, because earlier we didn't know what a list was. So I couldn't cover that in strings part. So let's say I have a text. I am Devendra, I live in India, right? And I just wanted to show what the split function does. So txt.split, and it will split on a white space. So what this does, let's run it and see. So what it is does is it is splitting the string into words, and the split is on white space, right? So we can see here in the output that it has been split at white spaces, and each word is an item in the list. So this is what split does. Another thing I wanted to cover was on immutability and tuple and list. So let's say I have a list 2, 4, 6, and let's say I have an item tuple. So tuple is, let's say I have a string here, let's say item 1, and then I also have a list here, right? So now we can see that we have a nesting here, that we have an immutable tuple, and inside that we have a mutable list, right? And because list is referred by address or location, it acts in a very different way. So let's say I want to copy. So I create a copy of the tuple. You have seen this earlier, right? And then we'll print it. So print this and the copy of this, right? Let's see what happens. Obviously, it will be a copy, but yeah, let's see. Okay, this was the original one, and this is the copy, right? Now let's say I do an append on L. L dot append. Let's say append a string hello. So what do you think will happen? Right? We have modified this L and added a hello at the end. But this list is a part of this tuple which is immutable, cannot be changed. What do you think will happen? Right? Let's see. Now we can see that the list was modified and hello was appended to the list. Even when the tuple is immutable, cannot be changed, we can see that the new list is in both the original and the copy, right? So this is sort of a copy which we call a shallow copy. So to address this problem that the copy is independent, there's a module. So this is our first import. So we are trying to import a module called copy, and this copy has a function called deepcopy. And when I do a deepcopy, it will work as expected. Copy dot deepcopy, we're copying T. Now, when we run this, we will see the result as expected. See, so what has happened here is that we create a copy first. So the copy is as expected, and then we append L, append hello to L, and L is the part of the original tuple, and hence this. So when we do a deep copy, all the nesting, everything has a new address, right? So this is something to be aware of, that when there are nested structure, nested list, anything which has non-trivial nesting, and when you want to make a copy, use this deep copy function.